Good afternoon. Welcome to another webinar. This afternoon we are talking about word indexes or predictive indexing. If somebody could just let me know that they can hear me, that would be great. Thank you. Okay. Predictive indexing or word indexes, it's something that applications, modern day browser applications use quite a lot, the Googles and the Bings, and one of the things that we thought of when we were looking at the future for DesignBais and what was important for us in Release 6, or important for all of our clients that are developing applications in DesignBais, was the ability to have something in the application that would allow end users to key some sort of text in and then find either customers that match the descriptions or application forms or reports that match that criteria. And in our website we've put an example of that particular function. And you can see here in the customer maintenance form. If you want to know how to get to this particular form, it's under the test drive menu option on the website main form, and you can see there that it takes you directly to this search bar. If you want to know how to use the search bar, just hover over the question, and it tells you basically enter something in there, and it will be reflected in a list. So I'll just put an A in there for the moment, and what that's done is that's found anything that has a word in the index that starts with A, and in this case you can see the word a cooler, as in a cooler drive, has been displayed, and this one's got accountants, and this one's got academy. So as I type this list is refined by what the user has keyed in here. So and this is very typical of search engines, the Google and the Bing type search engines. And this is actually really simple thing to construct as far as your application is concerned. In the website there is under code examples, there is a page here which is creating predictive text, which essentially talks about how this was done, how this customer maintenance form, how this particular predictive indexing was set up in this example. So if you go through this as well as this webinar, you'll have it down pat. So what I've built to demonstrate this is a very simple, very ugly but very simple form, and it essentially has two fields. One of the fields is called DBC key part 1, and the other field is called DBC search key.work, and essentially they're just two work fields that are on the form. One is going to be for the entry of my search key, and this key part 1 field will be we'll get the results of the search when the end user selects a value from the search. It'll get stacked into this form, and then we can make decisions as to what we want to do with that in some program logic. So let's have a look at right at the start the definition for the word index or predictive indexing. Now you'll see that I have a client definition, and I already have a definition set up for this particular file, and we'll just go through each of these fields so you understand what their purpose is. First thing is the index description, and in this case it's client suggestions. So if we go back and run the website form and key in ACC again, you'll see there that the text at the top of this window comes up as client suggestions. That text is extracted from this particular index description. So I tend to make this something meaningful. If you have a look at Bing, the way Bing works, it actually comes up and says suggestions for something like suggestions for your search or something like that. So I try to stick to that type of wording. Now the index file is dbfindex2 in this instance. Now that is the name of the file that the index values for the client file will be written to. So this is just an ordinary pick file with the various words and values that are extracted from the client file. The one at the front is the index number. So you can see that there's an index number 1 there, and there's an index number in the file. The reason we went to index numbers is that essentially it just saves us from putting file names in the file to make the keys a little bit smaller. I know disk is not really an issue nowadays, but I actually found that it was easier to view the index with just the index number than it was with an actual client with the actual file name in there. So the other reason to have an index number is that allows you to have multiple indexes stored in the same file. So this dbfindex2 file, I could have the index from the client and say from the creditors file stored in this index. And that just means that for smaller descriptive files, I can just load them all into the one index file, and I don't have to have a dbclient.index or something like that. If you want to do that, go right ahead. The choice is yours. The selection statement is essentially used if I only want to select clients that may be active or something for this particular process. Then I can put a selection statement in there to work out what clients I need to process for this index. Include a soundex. If I want to have a soundex match for the client description, so that way I get the Smith and the Smythe as the classic example for soundex. If I select that as yes, when the indexes are built and records are updated, it will write out a soundex equivalent of each of the descriptions that are indexed to the file as well. So that's entirely up to you if you want to include the soundex. What happens is in the search will run so if I key in Fred in my search key field, it will look at everything with a direct match or an exact match of Fred to start with. Then it will look for the soundex equivalents of that. So the list will display the exact matches, and then if there are any soundex equivalents. It uses a fairly standard soundex routine. It's as good as any soundex routine. We looked at a number of examples and the websites and what the various standard features of the database use, and we've come up with something that's a fairly well-rounded soundex routine. So then what I want to do is I want to tell the index build routine what fields I'm going to index. So in this case, these are essentially description fields, so the client name, the street address, the suburb, and the postcode. So in the client name, I'm saying alpha only, and it's a word by word, so to index the field on a word by word basis. So if I have Joe Bloggs, Joe and Bloggs will be indexed. And any numbers, in this case alpha only, any numbers will get removed from the client name. And as a standard, we remove things like pluses and underscores and dashes and dots, which typically make the index search routine a little bit unreliable. So we strip out all of those characters and just leave pure alpha in that case. I can also have pure numeric. I can leave it as entered if I want to maintain the numbers, because I know that I've got clients with numbers in their names. Then I would leave it as entered. typically, see, for street address, I actually don't want the number indexed. I don't want the number 3 indexed because they live at 3 Park Street. I just want Park Street indexed. So in this case, making that alpha only, I get rid of the lot numbers and the street numbers and unit numbers and things like that. And I only just store the alphas. So if I have 3/5 Park Street, the 3/5 is removed because the slashes and things like that are characters that are excluded for that. Suburb, I've left that as entered, and also WordBase. So if it's North space Sydney, I get North and Sydney indexed. Somebody's asked about what about non-alpha characters such as the hyphen, the apostrophe in a name like DaCosta. If you leave that as entered, that will maintain values like that for the searches. The other side of it, though, if I put that in this alpha only word, what will happen is, and I'll just key the result in the subroutine. So DaCosta becomes in the index DaCosta, like that. Now when the user enters DaCosta as DaCosta like that, what DesignBais will feed to the indexes, if it's an alpha only word, is DaCosta like that. So it will find it if you actually use the alpha only word construct. So postcode, I've just left it as entered because in some instances postcodes have a prefix like an A and a number, or a P or a B and a number. So I've just left that as entered. Uppercase, that's just what happens as it moves to the index. I recommend that you actually have that you do select uppercase. It doesn't really matter. You can be uppercase or lowercase, but I think as far as the index is concerned, it's better to be added to the index in either an uppercase or a lowercase. That'll ensure then that the entry for refining the index doesn't have to be a specific case. There's a subroutine here to decide whether or not the value is to be indexed. So you might have some additional logic that you may want to apply to say, I don't want this particular record indexed at all. So you set IER.text. If that's the case, the record doesn't get indexed. And if you want to modify the value that is being indexed, you can do that with DB value. So whatever program you call, if it's got the DesignBais, it needs to have the DesignBais comment in it. You could say DB value equals, just the whatever's passed, which is also DB value 1,6, because you only ever want the first 6 characters for some unknown reason. But you can do that manipulation in that subroutine at all. Now the combined for search, in this case we've got combined values for search against this client name. The reason for that is if the user enters Joe Blogs like that, I want the search routine to search in the order that the user's entered the values. Typically I wouldn't do that. I've just done that for demonstration purposes here. Sorry, that's just telling me that's not a valid subroutine. If I leave it as search any order, I could key in Blobs and Joe, or Blogs and J, and then it would find Blogs Joe regardless of whether it matched the order that the client name was originally in. So typically I don't have that way. I have it as search in any order. I might that can be useful for streets if you're not sure the order in the streets, and likewise with names, you're not necessarily sure how the end user doesn't have to know the order in which the given name and surname is entered in a client name. If you have the search in any order, they can just key in the order that suits them at the time, I suppose. So for my index, client name, street address, suburb, and postcode will be combined to a single multi-valued field and added to the index, and all the words and the cross-references all get done within the index structure. I've just been asked how is the index file built and rebuilt. I will tackle that shortly. Excuse me. So then I have fields to display. So when the user enters something in the search field and the results are displayed in this display window, I want to construct a display of the various fields. And so this part of the window is used to construct the display. So client name, street address, suburb, and postcode is what I'm going to display as the results of the search. I can put a prefix or a suffix against a particular field. So if I was displaying the phone number, I could put phone, fax, something like that. If the fact that the field wasn't obvious to be an email address, I could add email, and or I could put it as a suffix. So that's entirely up to you. That just allows you to make the detail a little bit more intuitive for the end user. Now I have a found color. What color am I going to display for the matching strings? And typically I have different colors for the various files. So if I combine multiple files in a search, which I will show you how to do shortly, it's easier to provide a visual cue for the end, or visual trigger for your end user, that they know that the green, after a while they get to know that green is always clients and red is always your creditors, for an example. So in this case I've used a hex style color of the red, green, blue hex. And I tend to do this. This just ensures that I'm not going to have a string that is going to show up as a replacement string in the actual display. So try to use hex colors if you can. Now the characters to link. In this case, what this example here is showing is that the suburb and the postcode will be linked together on the same line with a hard space. I could make that a dash. Instead of a space, put a dash in the line. So if I submit that now, that particular definition record, that's on a different system. You'll see the results of that when I run this search over here shortly. I'll just call that client record back up again. So what that'll do is that'll put the suburb dash postcode code as opposed to a hard space. Now I've got the display styles. The display class is what is the default style, essentially, from the style definition screen that is used for the standard list. So I'll just show you what I mean by a standard list. That's without the mouse over. You can see there Moscow Accountants is a transparent background. It's got black text and it's a particular type of font. So that is the standard display class. Then there is a selection class, and the selection class is when there is the mouse is moved over that particular field in the drop-down list, the selection class is what's displayed at that particular point in time. And it is nice to have a slight variance. I wouldn't get too gaudy about it, but it is nice to have a slight variance to let the user know that there is a mouse over event, that is the selected item at that particular point. And it's typical Web 2 sort of styling. Then you have the title class, and the title class is essentially controls the title for the drop for that box. So if we just have a look at those, I'll just open up a new tab, and I'll just grab that display class so you can see what that one looks like. So you can see there I've got a background color black. I've got a padding left of 0. Now the padding can be useful if you want to have an indent. If you're displaying results from lots of different index files, and you want to have some sort of spacing to note that to make the progression from one index to another a little more obvious, you can put some padding into this display field and the select field, so the heading and the actual details are indented. You can also use some background images if you wanted to do that in the styling, and some people want to have some sort of index, some sort of image next to each of these to indicate that it's an individual item, it's almost like a bullet point, if you like. So you can have that styling as far as a background URL, and then have a padding left of so many pixels, so that way the image of the bullet point and the text don't overlap. You can see I've got a border style none in that case. I've got a border bottom style of solid, which is why I get that big line at the bottom. I probably need to have a border bottom width of 1 pixel, because that's actually the default for that's actually probably a bit too thick. And then I've got cursor pointer. So the cursor pointer is essentially, I'll just flip back to that site. These lists have a lost focus event as well, which is why the list is actually disappearing as I switch between sessions, because what that does is it stops this key press event taking control. So there is a lost focus event associated with that, which clears the list, and that's just an automated design-based process on key press events. What was I talking about there? Oh, the cursor pointer, I'm sorry. As you move over each of the items, you get the hand cursor, or whatever the default pointer for your PC or browser is. So that's the display class, the selection class, and the title class. The maximum row height is 50 pixels, so that sets up the height of each one of these particular rows, so that way you don't have a situation, if you set the row height, you don't have a situation whereas if there's less detail it takes less space, you get a much more even display. And then there's a controlling field, which is dbc keypart.work. So let's just see, I'll come back and explain how that works shortly. So to build this index, once I've set this process up, there is a routine that you can run at TCL, and it's called dbi.p.dbfindex.build, and that will ask you the index name. So in that case, I put in, say, db creditor *3, which is one of the indexes. I won't actually build that now, but I'll hit enter. If I hit enter on that, it will go through. In this case, the dbfindex2 file, because both indexes that I've built into that file, the client and the creditor index, reside in the dbfindex2 file. It will delete any current index records for the third index, in this case db creditor. Then it will rebuild the index. There is another routine called dbi.g.dbfindex, which you can use if you're doing your own updates. If DesignBais is once this index is built for a particular file, if there's subsequent updates to that file, the indexes will all automatically be updated or deleted by DesignBais, if DesignBais does the writes. If it doesn't do the writes, then and your own routines are doing the writes, then there is a routine called db.g.dbfindex, and there is documentation on that in the release notes, in the manual, plus in the website under code samples in creating predictive text. I'll just get that form up. There is a section in this particular document somewhere. I should just do a search for it. Talking about how to call the update routine. Right, that's the build that we've just discussed, showing you how that's run, and then dbi.g.dbfindex and the usage of that. So if you're calling this routine yourself, there is a build type. So the index name to start with, db client *1 or whatever the file name and the index number that you've used. The other reason to have index numbers is that gives me the ability to create multiple indexes on the same file. So I might have a situation where I've collectively got all of the location and name information as far as the client's concerned in one index, and then I might have some other information about the client, say the contacts for the client, because I've got a multi-valued contact list on my client file. I might have that as the second index on the client file, so that way I can target the input if necessary. So I might have a field on my form which has just got contact, so if I key in the name like Fred, I can direct the search then to just look at the contact details. If I have a general purpose field where I'm just searching for Fred in any part of the system, then I can supply db client *1 and db client *2 to that index routine, and DesignBais will interrogate both indexes and bring back the results. So in this case, we've got a build type of build, update, and delete. If I set it to build and the ID is set to null, DesignBais will rebuild the index, i.e. do what this dbi.p.dbfindex build routine does. If I set it to update and give it an ID to build, DesignBais will update that ID to the index. Likewise, if I set it to delete, it will delete that ID from the index. So it'll remove the descriptions and the link to that ID from the update. So essentially, that's how you call this routine if you want to update the indexes yourself, and DesignBais isn't going to do that because DesignBais isn't doing the writes. So it's a very simple add to any existing update routines that you have in existence to do that. Right, so we've got that. Oops. So the next thing, I suppose, we've built our file. We've defined the index. We've built the index routine. The next thing to do is to add the key press event to a form. So as I was saying at the outset, I have built this very ugly form with just a couple of fields. So I have this search key field. The search key field is going to call my client program, and it's going to call that on a key press event. The way we perform key press, the way DesignBais invokes key press events is that it allows end users to just key naturally, and it waits for the input to pause for between 300 and 400 milliseconds. So when there is a pause, it will then prompt the server. So if I just hit A and wait for 300 milliseconds, you can see that went off and did that particular selection. But if I type in CONT quickly, that made a single hit then and found badly spelt contractors and containers and so on. So that just means that, and that's the way that the Google and the Bings and the Yahoos do a similar sort of function. The reason for that is just it's more natural. The user doesn't have to wait for the database to respond to each keystroke. So it's a much better experience as far as the end user is concerned. And you can see that this has just brought this box up here, and as I said, it's an ugly form, and I'm not really worried about where things go at the moment. It's just really to show you the construct. So now I'll demonstrate the code associated with that, and this is it essentially. So we've got a new event, which is the key press event. So in my routine, I will track for an event called key press, and the event source is the field that the key press events occurred, exactly the same as it would be if I was running a validation event. I get exactly the same parameters for that, and I get DB value, which is the value of the value entered to date. So in this case, DB value would be CONT. And the very first thing that I do is I say, if DB value equals null, then call the DesignBais routine dbi.g.display.drop, and essentially I've just got some bogus parameters in there, but you can essentially set all of these to 1, and in the example in the website shows that how that's done. That just basically tells this this display drop routine, don't display anything and just position the container, that box, somewhere on the form. And in this case, I'm just saying display it right at the top and make its default dimensions 1, 1, and then return. So what that essentially does is, if I get rid of this CONT now, that box disappears, and that's mechanically sound as far as an end user interface is concerned. Now, in this case, I've got an index to use as being 2 indexes, so I'll just get rid of that and just make it 1 for the moment. So DB client *1. So I'm saying for this particular search, use DB client *1, so index to use. Pass value I have assigned to DB value. Because this dbi.g.getDBFindex routine may call some DesignBais security routines, and in your security setup you've specified that you want to call particular routines to determine whether or not a particular client, in this case, whether it's valid to show that particular client in this inquiry. You may, in that routine, set DB value to certain values. So I don't want to corrupt DB value, so I just assign it to something else before I call the getDBFindex routine. You don't have to do that. It's just that I know in my routines I do have some security in place, and I do use DB value, so that DB value that comes back may get corrupted. That will return a key list, and the key list essentially will look like, I'll just key in an example here, DB client *3 pipe and a key. So what that allows then with this key list is, if you want to do your own security process, you can have your own security processes called after this get index and before the display index to further refine what has come back from the key list. So you can refine the key list variable essentially. Now I'm specifying also that this key list, that the depth of search for this particular index get is 20. So I'm going to return a maximum of 20 values from the database. The reason for that is because I might have 100,000 records in my client database that start with A. So if the end user hits A and pauses, I don't want to return 100,000 descriptions because A, that's going to take too long because I have to do 100,000 reads to get the descriptions for the client, in the construct that's specified in the word index definition, and potentially have to do 100,000 security checks for the IDs and so on. So I don't really want to return that, and it makes that process unusable. So typically I would have a depth of about 20. If I'm running multiple indexes, so as I will demonstrate shortly when I run the client and the creditor index, I'd probably reduce that down to 10, because I don't want the performance to slow down too much whilst it's checking multiple indexes. In some of our applications, we have one insurance application where we interrogate 7 different indexes in a single hit, and we're still providing sub-second response times with that, but the depth of return is in that instance is set to 10. So the display parameters. This is the X and Y coordinates for the box. So as you can see, when I type in A there, this box comes up in the middle of nowhere. I can position that box to make more sense, I suppose, by changing the by changing these values. So the X and Y coordinates, the width and the depth of the box. So that gives you the ability to customize the size and the position of the box to match the type of display that you're returning and the depth of the return as well, and also to match the screen. So then I'm going to call the display dbFindex routine. Now you might have your own display routine here. So you might use our get index routine and then not use our display routine here. Oops, I'm sorry. Our display routine, or alternatively, you may use your own get routine. You might do a select because you know the file's only small at this point. So go off and do a selection of the file yourself, and then call our display routine to display the results of that if you wanted to do that. You would just need to make sure that the keylist variable had a construct that matched the word index. What a lot of people are doing is they are building the word index definition, but never ever building the file. So that just gives them this description point here. So the display definition, so they can use our dbi.g.display dbFindex routine and with these parameters, but not actually ever build the file, because you've got your own selection routine. Okay, so the index to use. So again, that just mirrors what we've supplied up here. So it's either one index name or multiple index names. The pass value, so again db value, and the reason we do that is so we can find the various values in the descriptions return in the key list. So we can highlight them to in the manner that the index descriptions define. Return array just gives you a return array of what was actually displayed. If you want to interrogate that to do something else, you can do that as well. The display parameters are these display parameters, which is the positional parameters, and then we've got the passed from variable. There's also a passed from variable up here. So I could specify, in this case, dbc client name and dbc client name down here in the display parameters. So I'll just compile that. So what that means now to this routine, if I key in an A, that will only find A that appears in the client name. So that allows me to target the input or the search to a specific part of this index. Even though the index is thrown everything together and created, say, Apollo Fabrics West 1st Avenue, Cambridge in the index, I can still target the input individually by specifying in my program this passed from variable, in this case DBC client name. Now if DB value is actually multi-valued, I can specify what value each multi-value is passed from. So I could say the first part of DB value is DBC client name, and the second part of DB value is the street, is the suburb, and so that way it'll find both of those targets, which is useful if I'm looking for a value of a street and I already have the suburb. So I could specify DB value, let's say DB value was multi-valued because it was supplied from two different fields because it had already been supplied the suburb. I could say that the first part of DB value is the suburb, and the second part of DB value is, say, the street address, like that. So what would happen is that if DB value was a complete string like North Sydney value mark Park, or PA, that would look directly at the suburbs and find North Sydney as a complete unit, and then it would just return the suburbs of North Sydney, and then that would find any street that started with PA. So if my user had already completed North Sydney as a suburb, then this value mark PA would find any street that started with PA, so Park Street, North Sydney, Pacific Highway, North Sydney, that would find. And as the user then, say, put the C in for Pacific, it would give Pacific Highway, North Sydney, which is very useful because if I don't supply this passed from variable and the user keys in North Sydney, Pacific Highway like that, that would also find PAC in the suburb. So you can end up, if you're looking for North and say Park, like that, you would end up finding, you could find North Street Parkville, where in actual fact you're looking for Park Street, North Sydney. So it gives you the ability to target the way the indexes are interrogated. So in this case I just want that as null because I'm actually looking at the entire contents of the index. Okay, so the results of that is go off and find from the client index the value that's entered and return that up to the first 20. So we look at this and I key in, now I key in ACC, and it's found all the accountants. If I type in CAN, oh, it's found Bedford Candles. That must be still targeting the same. Where's my program gone? I'll just recompile that. Doesn't look like the program's gone live straight away. I don't know why, but anyway. So I'm targeting the accountants, and that's just returned everything that's matched to client because the program, for some unknown reason, the program hasn't been updated. And it doesn't have anything else in there. It's just gone through and looked at the client suggestions. What I can now do is specify that I also wanted to update. I also wanted to search across the creditors file for those particular, for whatever users, for whatever entry the users had. And let me just restart that. So now if I key in A, I get client suggestions, and down the bottom here I get credit suggestions, and there's not too many of them because you can see there's just found AND as a connective there. Now in the subroutine to call in the word index definition, you can get rid of this stuff if you choose to. We don't have any blacklisted words as a default. We did to start with, but we actually found that that caused more problems than it solved. So you can make those decisions in your subroutine. So you might want to make sure that all ampersands are converted to ands, or vice versa, all ands are converted to ampersands. That's in your rules for updating the index. You can specify that. So if I type in green, you see I get client suggestions at Greenville and Greensboro and so on and so forth, but I also get client suggestions from Billy Green Couriers and Green, Blue and Red Payroll Services. So then the user's going to click on this now. So when the user clicks on this, the only thing that I am doing at this particular point is filling this key part 1 field. And that was a rule in my index. My index definition was I have a controlling field called DBC key part 1. So that means any form that I want to include this client search on, I must have a field named DBC key part 1 in this instance. You probably want to name it something a little more apt than that, but so if we have a look at my creditor index, DB creditor, you can see that it also stacks to DBC key part 1. It could stack to a different field. That's entirely up to you. It also builds to DB Findex 2. So it looks at exactly the same file. So the result is, when I selected something from the client list, it updated this key part 1 field. So at that point, I can then make decisions as to what I want to do. I have all the information I need on this particular field. So I have the index and the value returned. So I can have some program logic in my routine now that specifies what do I do when these values what do I do with these values, full stop. So if we have a look at this routine, this particular field, DBC key part 1, it calls db.i.db client again. So I get a validation event from DBC key part 1 in my program that has a db value of the value that has been passed, that has been stacked into that field. So essentially, I can then make decisions as to what I want to do. So I'll just see whether I've got, I don't have anything in there. So I'll just stack in a straight DBDS. So when I run this, call something up in the list, accountants, so that you can see that that program was called straight away. So at that point then, I have the ability to do a DB pass DB value then to the key field on the form. So if I have a key field on my form, and I'll just add that to it now, client code, add, and I'll just put the client name on there as well, just so we can see that the read occurred. Add a read to the client code step, and that should be enough, except for I need a read type. So if I come down here, C0025, you can see that that has performed a read. It looks like I've also got that as an output field there. I'll just get rid of that. So that's my client code field. So what I need to do in my routine is strip the ID, add a case statement. Okay, so otherwise, if say case 1, I'll just say DBDS, I don't have a creditor screen, so that'll just show you that this gives me the ability to write some logic now to say, what do I do with this key? So if I have a situation where I have every description that is meaningful in the system built into these various DesignBais indexes, and the end user comes up and says receipts, it'll look at, and I can say look at clients to see whether any of the clients have receipts in their name. So you look at the creditors to see whether they have any receipts in their names, have a look at my stock system, see whether receipts has anything in that. Have a look at my applications to see whether there's anything in my applications descriptions that have receipts in there. Oh yes, there is. It's called bank receipts. It's called receipt print or cash receipts, I should say. So then I can display cash receipts, and the user clicks on cash receipts and says yes, that's the one I want. Then I can put some logic in my routine to say, well, was it a client that was returned? Yes, go and do something. Was it a creditor that was returned? Yes, go and do something. Or a stock item or an application item. If it's an application item, process stack that particular application item. I can also add some logic to say, what screen am I on at the moment? Oh, okay, it's a client maintenance screen. What's the key? Okay, well, here's the key for that particular item, so I can work out what to stack to the subform if I need to do that as well. So you can provide a very intelligent interface to the end user. It just means that you need to think about it a little. And the other thing that you can do is you can build a header to all of your forms that have a very simple construct, which is essentially a field and a search string, similarly to what I've done on the website, but it would be on top of it would be a header that was on top of all the forms. So you might be halfway through a client maintenance exercise or an order or something like that, and a client rings up and says, I've got a problem with an invoice. So I could come up to the search key and the invoice number, and it says, okay, I found invoice number, it's an invoice, and then go and call the invoice number, the invoice screen, and stack that invoice number through. So that gives you that type of ability. And then when that's finished, the user can close that invoice inquiry screen, and then they're back in the order that they were in before they got that inquiry. So it means that your application allows end users to duck in and out of various parts of the application without really messing up where they are at that point. So just to demonstrate this very, very simply, if I key in ACC, select one of these. Did I actually compile that routine? I probably didn't. Let me do that. You can see that the index stacked this description into the key part 1 field. The key part 1 field automatically ran a process after, or a validation event, and the validation event then said, well, what happened? What was it that was actually in this DBC key part 1? What actually happened? Oh, it was a client index that was pressed, that was returned. Okay, therefore pass the key to the client field on the same screen. I could at this point decide to say process stack equals db client demo base. I'm not even sure whether that is a particularly, we'll find out. Stack that and as a layered form. So we'll just do the same example. So there's my client maintenance form stacked as a layer past that particular value. So that gives you a demonstration of how I can have a single purpose selection form, selection field on every form, and then based on the results of that selection pass different values to other subforms. And then if I look at red, select the creditor suggestion, you can see I don't have a creditor screen at that particular point. So the logic is sound there, so I could call up a creditor screen at that point. So this is really designed for the Australian audience to produce what we call the Ned Kelly interface, which is essentially a single view of your entire application, and allow the end user to just basically key whatever they want into that single field, and then get the results from that. That's really as simple as this process is. It's not something that's complicated at all. It's just a matter of working out how you would apply it to your application. It's very easy to implement within your existing application. You can just have a header form that performs this logic, if you like, and then add that to all of your forms, so that way all of your forms have this construct, or a percentage of your forms have this construct. So as I said, it's really that simple. That's pretty much where I think we need to end it today. If there are any questions, I'll hang on for a minute or two to see if there's any questions that I can answer beforehand. So as I said from the outset, there haven't been any questions as yet. As I said from the outset, there are very good examples in the creating predictive text as to how this is done. So the code examples are in there, so you can just cut and paste. Sorry. Somebody's just said that they didn't quite understand the North Street and Park Street example. I'll just very quickly, for those who want to hang on, I'll just explain that again. The key press event, because my index is built with multiple index names, so if we go back to the client, you can see that it has client name and street address and suburb and postcode. I can tell the index, I can tell the index search routine what component the user has entered, and that is in this passed from variable here. So in the example I gave earlier, I could say that DB value is directed when I was targeting a particular index, in this case the client one, the value that was entered was directly from the client name field. So that means that even though the index has client name, suburb, and street name and postcode, that this DB value, or this pass value variable, is directed just to the client name. So when we see that in action with AWC, it's just found accountants. So if I put in FLA, I don't get to see that suburb that was FLA, because I'm saying that that input is targeted directly towards the client name field. Now, if I had another field on my form that already had suburb in it, I could say, let's say it already had North Sydney in the suburb field. I could then say that my pass value was dB value, so the value that was just entered, plus the suburb, say North Sydney. And make that value like that. So the pass value is constructed of two elements. So what I would do then is I would say my passed from variable, and I'll add that to the search, is DBC suburb and DBC street address. So what that would do, now if I just had, I'll just put North in there instead of North Sydney. So if I passed that to this get index routine, suburbs returned must have the word North in them. So it will find North Sydney, North somewhere else, North Melbourne, there you go. So it will find suburbs that have North in them, and it must have North in the suburb. So what that allows me to do then, if I was looking for, say, Pacific Highway, and this dB value was Pacific, then the suburb must have North in it, and the street address must have Pacific in it. If I don't have this construct, and I had park, like that, I could find North Street. So the results of that might be North Street, Parksville, if there is. Oh, well, there's Parks in Canberra. So that could find North Street in Parks. So having this passed from variable specifying that this has to be found in suburbs and this has to be found in street address stops this sort of construct, because it says that it wouldn't find North Street because North only pertains to suburb in that case. Okay, somebody, they've just asked, okay, they understand that, but how would the user interface work? Typically, if that was the case, I would already have another field on the form that had suburb in it. So I would have already filled out the suburb. So you might have a situation where you've got, if you take the Australian streets and suburbs and you put them all together in a word index, you end up with, I think it's about 800 and something thousand words. So in that situation, you might want to have two fields on your form. One is, what's the suburb? So that way they put in NORTH, and then you attack the index just for the suburbs. And when they key in NORTH, it says, oh, well, here's North Sydney, here's North Melbourne, and you click North Sydney is the one I want. Then you get to the street address field, and you pass in, and they key in Park, you pass in then North Sydney to the get index routine and say North Sydney is a suburb and Park is a street address. I think that probably answers that. If it still hasn't answered that, drop me an email, or drop an email to support@designbais.com, and we'll do a session outside of this. Okay, so that ends this webinar. Thank you very much. If for anybody, if they have any questions that they didn't think of during this, send an email to support@designbais.com and we will reply. Thank you very much. Cheers.